Have you ever wondered about the mysterious world of prime numbers? Well, you're in luck, because today we're going to dive deep into the fascinating patterns that exist within these mathematical marvels. First things first, let's talk about what prime numbers actually are. In simple terms, a prime number is a positive integer greater than 1 that has no positive divisors other than 1 in itself. Examples of prime numbers include 2, 3, 5, 7, and so on. They are the building blocks of all other integers, and their unique properties continue to baffle and intrigue mathematicians around the world. One interesting pattern that emerges when looking at prime numbers is their distribution. Initially, it might seem like prime numbers are randomly scattered throughout the number line. However, mathematicians have discovered that there are certain patterns and trends that emerge, known as prime number gaps. Prime number gaps refer to the difference between consecutive prime numbers. For example, the prime number gap between 3 and 5 is 2, and between 7 and 11 is 4. These gaps can vary in size, but as numbers increase, the gaps tend to become larger as well. One of the most famous conjectures related to prime number gaps is the twin prime conjecture, which suggests that there are infinitely many pairs of prime numbers that are only 2 apart from each other. While this conjecture has yet to be proven, there have been significant advances made in recent years, thanks to the collaborative efforts of mathematicians and computer scientists. Another intriguing pattern within prime numbers is their relationship to patterns in nature. The study of prime numbers is closely linked to the field of number theory, which examines the properties and relationships of numbers as abstract entities. Scientists and mathematicians have discovered that prime numbers have an uncanny resemblance to the patterns found in natural systems. For example, the Fibonacci sequence, a well-known mathematical sequence, exhibits a strong connection to prime numbers. In the Fibonacci sequence, each number is the sum of the two preceding numbers, 1, 1, 2, 3, 5, 8, 13, and so on. If we examine the sequence and highlight the prime numbers within it, we start to see a pattern emerge. The prime numbers in the Fibonacci sequence tend to occur at regular intervals and exhibit their own unique distribution. Furthermore, prime numbers are also deeply intertwined with the concept of randomness. While prime numbers themselves are deterministically generated, their distribution seems to mimic the behavior of random numbers. This property has made prime numbers instrumental in fields such as cryptography, where they are used to secure sensitive information. One of the most famous applications of prime numbers in cryptography is the RSA algorithm. This encryption technique relies on the difficulty of factoring large composite numbers into their prime factors. By using prime numbers, RSA enables secure communication and data transmission over the Internet. But the fascination with prime numbers doesn't stop there. Mathematicians have also explored the connection between prime numbers and other mathematical concepts, such as geometry and calculus. For instance, prime numbers have been linked to the distribution of prime spirals and prime polygons. Prime spirals are patterns formed by connecting prime numbers on a spiral grid, starting from a central point. This spiral shape has been observed in various natural phenomena, including the arrangement of seeds in sunflowers and the spiral galaxies in our universe. The study of prime spirals opens up a whole new dimension of exploration, where number theory and geometry intersect. Similarly, prime polygons are shapes that can be formed using only prime numbers. For example, a 5-sided polygon, a pentagon, can be constructed using the prime number 5 as the side length. This connection between prime numbers and geometry highlights the unbreakable bond between different branches of mathematics. In conclusion, the study of prime numbers is a never-ending journey filled with endless patterns and captivating connections. From their distribution and gaps to their relationship with natural patterns and their applications in cryptography, prime numbers are a never-ending source of fascination for mathematicians and scientists alike. So, the next time you come across a prime number, remember that beneath its simplicity lies a world of complexity and mystery waiting to be explored.